All righty, up and running. Let's have a little chat about cubics, and let's look at it from different perspectives: geometric, numerical, graphical, and symbolic. I don't think I'm doing anything here that should stress you. I'm just drawing some different size perfect cubes. A -3 times -3 times -3 yields a volume of -27. And we'll not discuss negative volume at the moment, which is working with some numbers. Let's talk about -2 giving -8, -1 giving you -1, 0 giving you 0, 1 giving you 1, 2 giving you 8, 3 giving you 27. All right, so let's zoom in on the volumes. -27, -8, -1, 0, 1, 8, 27. They do appear to be increasing at all times. Although the magnitude seems smaller here, but I don't know how we want to discuss negative volume. But the numbers themselves on a number line are definitely going up. And we have a number line on the other side of the board. We'll show you that in a second. But, you know, volume comes from three sides: length, width, and height. And these are perfect cubes. And so you were more familiar with X's and Y's, but side length gets us volume. And ax cubed plus bx squared plus cx plus d can be written in graphing form, similar to the quadratic graphing form, ax minus h squared plus k, which gets rid of the linear term. This graphing form gets rid of the quadratic. Doesn't mean much to you what I'm saying right now. It's too early in the term to have that discussion. It would be a good 10-15 minute lecture, and it's coming soon. But we'll be looking at the interplay of the cubic numbers and a linear aspect, and that's how we'll start to visualize cubics. So we're going to look at it from a graphical, numerical, symbolic, geometric standpoint. Here's the geometric. Geometric is high-tech. It's a box. I'm going to call it a 2 by 2 by 2. And what we're going to do is we're going to increase the volume slightly, because right now we've got some pretty big jumps. We got jumps of what happens if the side length goes up 1 unit. Well, if it goes from -3 to -2, the volume actually goes up 19 units. That's the difference between -27 and -8. Then it goes up 7, then 1, and then 1 again, and then 7, and then 19. So there are definitely some symmetric issues here at play. And we're going to find that HK in the cubic has a lot to do with, not a lot, has to do with minus b over 3a, and the function evaluated at minus b over 3a, and we call that a point of inflection, which I'll elaborate on over here. 1596, René Descartes was born, famous French mathematician and philosopher. He thought he proved his existence by saying, "I think, therefore I am." I guess he went into a store, well, I won't tell the joke. Another time, perhaps. All right, so he gave us this coordinate system called the Cartesian coordinate system. Cartes, right? Descartes, Cartesian coordinate system. And, you know, we've got some very useful numbers here, because we don't need a calculator to do -2 times -2 times -2 to get -8. Right? We don't have to use a calculator to do -3 times -3. But what we have here is, on average, between those two coordinates, you're going up at 19 to 1, then 7 to 1. And I was using half a marker for 1 unit of change. This one looks a little bit far, but that's all right. So that's going up at 1 to 1, that's going up at 7 to 1, that's going up at 19 to 1. And I don't know where this is going up at 1 to 1. Pretty flat there. And then it goes up 1 to 1 again, still going up 1 to 1, then 7 to 1, and then 19 to 1. And we get this nice smooth curve that doesn't look smooth here, because I'm making kind of step jumps from one dimension to the next. But what's happening in between? Well, it's changing at different rates. And how do we measure those different rates? Something we do a lot of, especially at Algebra 1, y2 minus y1, x2 minus x1, except I'm making these changes very small. So I'm going to go from 2 to 2.0001. And I didn't need a calculator for this because there's patterns. I did need a calculator for that one. I'm not used to that one. But if you cube 2.0001, you get 8.0012, 0006, 0001. You can check it on a calculator. I'm pretty positive that's the pattern. And yeah, NASA only uses 8 decimal places for accuracy and sending things out to space, I guess. So, 8 decimal places takes us to here. So really the major amount of change that's taking place at x equals 2.01 is it's between the volume of 8 and 8.0012. It's basically changed by 0.0012. I mean, we could keep pushing those zeros out forever and gain more accuracy, but that's the change. 0.0012. They're just like miles per hour, volume per side length change gives us a sense of rate. Miles per hour, right? Amount, time, that sort of thing. Okay. And then we can see that changing by 0.0001 consistently gets us a new number, but that new number is slightly bigger than the previous volume. So what's going on geometrically? Well, okay. Well, here's your 2 by 2 by 2, right? Let's put it there. Let's thank you. Refill cartridge, board master. Thank you. Whatever company did this. And I am going to put a little more volume on the box by sliding a layer. All right. And that layer has volume. And that volume has got to be 0.0012 in this case. So what happened? Well, the old dimension was 2 by 2, right? 2 by 2 by 2. So this is 2 units. And when I slide this on, that new side length just got a little bigger. And to maintain the shape, so did the width and the height. All right. So we are capturing a new layer of volume right at 2.8. Okay. So if I were to zoom in, this rate of change could be captured by zooming in because it'll look linear. And then we can perform volume 2 minus volume 1 over side length 2 minus side length 1. And side length 2 minus side length 1 is the 0.01. And volume 2 minus volume 1 truncated is 0.0012. All right, so now a deeper dive into what you're looking at. Can you describe what you're looking at? Let me get just one of them. What are you looking at? Hope you said it's square. How many are you looking at? 3. Well, that's area. So what would the area of this be? Well, the area of 1 square, 2 times 2, 4. But we have how many of them? 3 of them. Oh, geez, 3 times 4. Must be a coincidence. Yeah. Of course, I could do this one down here, 327, and let's do 5 decimal places. Well, then that's going to be 27.00027, 00009, 00001. Believe that? Oh, 27 to 1 ratio of change. Why? Because if it was a 3 by 3 box, if it was a 3 by 3, you'd have 9 units of area. Now the question is, where's the volume coming from? I see area. Oh, the 3rd dimension. Can you see it? Can you see 0.01 for height? Okay. So these things are taking place. And I think it's very important that you hear these conversations now before you drop out of calculus and hear them, because that's what most people do. They get to calculus, which is when you finally start to work with math opening the door to using it, to study things, to really study things, and to make things. And It's the pinnacle, is to get the calculus and understand it and then continue on if you so desire. But these concepts need to at least be mentioned. All right, so what's going on here? Surface area. Now, where would surface area change least quickly? I mean, if you think of surface area as painting, you know, putting a layer of paint on the three sides. Well, as the box gets bigger, you got to use more paint for that split second increase. But where are you not painting much paint for surface area? Where would that be? Well, I hope you'd say right at the origin here, right? Why isn't the surface area changing very quickly there? There's no box. There's no box. And this is the place we call point of inflection, because there's a change in shape here. And we call that concave down. We call this concave up. And later on in math, you'll start talking about three things: position, velocity, acceleration. Well, you're not going to be able to work with those things unless you get a good foundation at this level. Okay, so the foundation's everything as far as how you're going to do 3 years from now. And that's not that long from now. A lot has to take place in 3 years, a lot of maturation, mathematical maturation. And so I suggest you think about these things. You give them some good thought. We're going to develop this much further. Going to take this much further, but these are some basic concepts. Rates of change are very important. Okay, when did we see that last? In the last 2 years? When we had diagrams like this, right? And what was that? COVID. Transmission doubling every, I don't know, every 5 days, doubling every 5 days. And what was said? What were all the, you know, the health professionals saying? Flatten the curve. Flatten the curve, because you're going to learn the area under the rate curves gives you about. I'm starting to ramble. I'm probably losing you now. So, okay. So the rest of the go around now is going to be the worksheet that you did today. You're looking at it again. All right, trying to get those neurons to fire quickly and easily. And so let's have at that. All right, we just put a few things in front of us here that I think are real important to look at and start thinking about at a young age. And that's what I'm doing with you. All right, so now we had 5 factoring problems. 5 plus 10, 5 times 1 plus 2, and I hope in today's class we said what's the first rule? The first rule of writing products. This is addition, that's multiplication, and the first rule is taking out what's common. And that's where you got to use it here. What's common? 5 again. Okay. Multiply that out, I get this. I got the marker, which is dying on me, but I will see if I have another one here. Yeah, no, we're going red. All right. Ink's expensive, but I'm going to go with it. Start of the video. X squared minus x minus 6. Trinomial, binomial factoring. All right, so what numbers? Well, x times x has to be true. Remember, you're pausing the video. And then we got to look at numbers times x that are factors of 6. 1, 2, 3, 6. 1 and 6, that doesn't get me 1. 2 and 3, oh, that does it. 2 and 3, yep, that gets me 6. And they're 1 apart, and I want it to be negative, so I better give that guy the negative. Yeah, all right, so that's true. Then we got, you're pausing the video for all these in case you want to get a little more time for yourself. 2x squared plus 4x minus 30. Well, first step, take out what's common. 2 times x squared plus 2x minus 15. Now we're looking for 2 numbers that multiply out to 15 and are 2 apart. I think we can pretty easily see that's 3 and 5. And then we got the same issue again as to middle term. We want middle term positive. So we'll give the positive to the bigger number. All right. And then we got 3x squared minus 10x minus 8. 3x squared minus 10x minus 8. And I'm doing these quickly, but you can take more time. Well, we definitely know we got a 3x, an x, and factors of 8, 1, 2, 4, 8, but I'm writing them here because those numbers are going to be 3 times bigger. I don't think we want 8. 8 and 24 and 1, nah. But 8 and 1, 11. No, so I mean, I really do have to look at the 1, the 2, the 4, and the 8. I do have to look at those because they could be tripled as well, and they're mates over here. But I am doing that already. Oh, lost my train of thought. Let's just find the answer. So I think we're looking at a 4 and a 2 because 4 times 3 is 12. 12 and 2 can combine to be 10. So I want negative, so negative, positive, and then that one's done. All right, so we're going to do 5 of those every day so that your factoring skills by midterm can be used in, you know, doing some addition of algebraic fractions. And I should have this thing. God, I hope that. Yeah, that's better. Still not the best. All right, apologies, but not going to go back and make that all over again. All right, so where are we? Linear function. Sometimes it's helpful to write in a tabular format. 5, 2, 8, negative 23. So therefore y equals, I don't even care if you write y equals anymore. X minus 5 plus 2. Change from 5 to 8, operational change of 3, because we have 8 minus 5 to the first power. That's the operational change. I want to keep saying that so you don't develop a linear mindset. From 2 to negative 23 is down 25. Okay, so there's the linear. All right, now we're going to do 1 comma 3, 5 comma 24. Yep, and quadratic. So we got x minus 1 squared plus 3. The change, quadratic change, is 5 minus 1 squared, which is 16. That number is not going to work. From 3 to 24, 21 units of change does work. Pause at the moment here. I forgot that we had an introduction of this term in yesterday's class, I believe. And we talked about that being the square root of 4 times the square root of 10, which could be rewritten as 2 root 10. So we want to do a couple of those problems right now, and then I'll be including those in tomorrow's worksheet or the next one, whatever day we're talking about here. All right, so let's just look at the square root of 32. I said 36. Square root of 32, right? You're pausing the video, obviously, but this one could have been the square root of 16 times the square root of 2, which is 4 root 2. And I'll be asking you to memorize root 2, which is approximately 1.41. You want to know that. You definitely want to know that going forward. So without a calculator, I have a pretty good approximation of that. So let's see. 4 times 1, 4 times 4, 16, carry the 1. So 5.64, I believe. Yeah, it's got to be between 5 and 6, right? To get 32. So good, a little approximation there. So we'll be doing that. We'll be doing problems like the square root of 7 times the square root of 14. That'll be on worksheet, next worksheet. So that's the square root of 7 times square root of 7 square root of 2. And again, I'm hoping that, you know, that this means more to you as the term goes on. Square root of 7 times the square root of 7 by definition is 7. All right, so this is 7 root 2. And what's the last square root that comes into play here? Something like simplifying the square root of 18, a squared, b to the 3, c to the, I don't know, 22nd, something like that. Let's make this b to the 9th. All right, so how would you do that? Well, the square root of 18 is 3 root 2. All right, square root of 18, square root of 9, square root of 2. So we know that. We also know that we could write a squared, b to the 9th, c to the 22 to the 1/2 means square root. And we have rules here, multiplication. Okay, so what's the square root of a squared? Looks like a can come out. B to the 9th to the 1/2 could have been written as b to the 8th times b to the 1/2. And I think 1/2 of 8 is 4. So I think you can take 4 of those out. One of them stays in. And 22, square root of that, c to the 11th. So we'll be doing one of those every day for the rest of the term. Yeah, so you got until basically the middle of December to prove to me you can do that. I think I'm giving you plenty of time to learn it. So the brain might have to, you know, settle in a little bit, see it several times before it starts to recognize things and work with it easily. But that's our new topic coming into the workshops. All right, so what do we got? Name 3 points, maybe? -7 over 101. I can't imagine I'm doing anything other than name 3 points. Now, this is a product, by the way. That's a product. Yeah, we always want products to equal 0, right? Because we don't need a calculator. That happens when I use -40. And I think we've been talking about the change in x. Well, that's an x. I think I'll change it by 101, 61, 162, 263. I think I can do that. Of course, I need a y value here. So let's see where it's over there. Where am I? Oh yeah, -100. -100. Well, okay, so -40 gets the product to disappear. I guess that's my first y value. And then I think I'm going down by 7. It's always nice to check one of these. Let's do 162. And let's go -114. Because I've made very many careless errors as I get older. And let's just check that out. 162 plus 40 is 202. Oh, I like that. That's a multiple of 101. 101 goes into 202 twice. And so that's 2 jumps down, -7 twice. Oh yeah. -14, -100. Oh, looks like I can do this. Seems like it's working out nicely. Got some knowledge. Can plot those points quickly and easily. Got myself a graph. One of the skills you want coming out of this class. All right, 5x minus 2 squared. And feel free to take 5x minus 2 times 5x minus 2. 5x, boom, boom, inside, outside. You go ahead and do that. I'll just take the shortcut. 25x squared, double the product. -10 becomes -20. I think you can see -10x, -10x, and +4, always a positive at the end. Squaring the numbers, going to get positives, unless you square 0, which is why you have a minimum on y equals x squared. Next, x to the 30th minus 5y to the 4th. X to the 30th minus 5y to the 4th, squaring. All right, so that's x to the 60th. That's -5 minus 10, doubling it. X 30, y 40. That's just number x 30, y 40, y 4, excuse me. And then squaring the last 25, y to the 8th. If you're struggling in class, hopefully you're taking some time to think about these things. All right, I don't know what I asked you to do with g of x, 48, 2, x minus 4 plus 5. Well, I can see a jump of 48. Let's make it smaller. I can see a jump of 48. And then I can see a jump twice that, 96. Then I can see the same distance away, 192. So if you're wondering where the base of an exponential function comes from, you're looking at it. Of course, I'm doing this change above 5 units. So I got exponential growth. What's the first x that's important? Looks like 5. 5 minus 4 gets me 2 to the 0, 2 to the 0. Hope you're getting better at that, is 1. So I get one jump of 48 on top of 5, 53. And then, you know, the next easiest number is 2 to the 1. So I guess I'll put in, oh, I meant a 4 here. Careless error. Okay, 4 minus 4 gave us that 2 to the 0, so excuse me. Now the 5 gets us the 96, right? 5 minus 4, 2 to the 1, 2 to the 1 times 48, jump at 96. And that occurs at 5, comma, oh, getting tired. 96 and 5, there we go, 101. All right, so that was a quick graph of that. You have your worksheet, hopefully. You're looking at what problems are coming your way. Okay, I'm gonna do the inverse. The inverse of 48 to x minus 4 plus 5 would be x minus 5. Rid of the addition. Getting rid of the multiplication. Getting rid of the 2 to the. And adding 4. Obviously, the 2 to the log base 2 of is going to be the hardest thing for you to master. Just going to keep putting it in front of you every day. Every day. So let's take our 101 and see if it comes back to, what was it, 5 gave us 101 up here? Let's just check it, see if it works. Let's put a 101 in. 101 minus 5, 96. 48 goes into 96 twice. What do you put on top of a 2 to get a 2? A 1. And 1 plus 4? 5. So I hope on some level you can at least see that work. That first stage of learning is following. I hope you followed that a little better. All right, 1/25 to 3 to the negative 3 halves. 1 over 25 to the minus 3 halves. I'll just talk you through it. I'm going to flip it immediately. That gives me 25 to the 3 halves. I just did that operation. Now I'm going to do the square rooting, excuse me. Roots are in the denominator. I'm going to take the square root of 25, which is 5, and I'm going to cube it 125. Hopefully you're learning those operations as we speak, as I speak. Next one, where am I? Log 125, 25. This is trying to find out. Trying to find out what I put on top of that to get this. Now you can do it conceptually. You can take a cube root. Cube root of 125. It's 5. 5 squared is 25. So we know the answer is 2/3 from a conceptual standpoint. How do we get it mechanically? Well, we start with 125 to the what? Equals 25. Got to be the same base. Looks like 5 cubed to what? Equals 5 squared. Well, bases are the same now. Base 5, because I can move that 3 there, right? Multiplication. And so 3x equals 2. And there's our answer of 2/3. Square this number and take a cube root, or take a cube root and square it. It's easier to do the latter. All right. Log 9 to get 127. So the same kind of issue here. Right. So we got to do what? We got to do 3 to the 2x equals 3 to the negative 3. So minus 3 halves. Well, look at minus 3 halves. Well, I hope you can see why we got a negative. We got to make a fraction out of this. I mean, 9 over 1's got to flip. Taking the square root of 9, which is 3, and 3 cubed gets us 27. I hope you're getting a little more familiar with those. About the 4th time you've done them. Log 10. Just recognition. It's 1. You see the word log with no base, it's understood to be base 10. Pythagoras. Z. 3. Z, 7. Drawn in standard position. There's the origin. We're looking for that x. 49 minus 9, 40. So it looks like this is the square root of 40, right? What I did. Didn't have to draw this too many more times. All right, Mr. Big minus Mr. Small gets us Mr. Medium. And that's by definition is a square root. The square root of 40, we talked about at the beginning of class, 2 root 10. All right. Flying here. 0, 0, 5, 4. Distance from 0, 0 to 5, 4. Well, that means that's a 5 and that's a 4. So we can use the same concept here. 25 and 16, square root of 41. All right, so that's not too bad. Hope you got that. You might see that on an SAT. Minus 2/3 x plus 8. I say graphically first. Well, that's a line. This is a product. What makes that product 0? Plugging in a 0. Easiest number to work with. 0 gets you 8. So we'll plot that. Good old Rene Descartes. 0 gets us 8. All right. And then we got what on the other side? 4x minus 2. Well, that's another line. Put a 0 in, you get -2. That'd be about there, I think. And we're going up at 4 to 1. So I'll go that, and I'll do it 4 times. About like that. Lost my. All right. Oh, down 2 over 3. I should have gone down to. That's not too bad. Anyway, we got a small x, probably near 2. Rough estimate, probably near 2, because I botched that minus 2 over 3. All right, so how do we get it? All right, minus 2/3 x plus 8 equals 4x minus 2. Now, something just happened here in this class. Oh, we're solving an equation, and it looks like it's the intersection of 2 graphs. I don't want that moment to pass. I got a feeling that all the equations you're going to solve in your high school career could very well be the intersection of a couple of graphs. Let's see if we find something that makes that a non-true statement. I got a feeling it's true, but we'll keep an eye on it. All right, like this one here. So I don't like fractions. So let's look at 1 plus 2 equals 3. Let's multiply everything by 10. 10 plus 20 equals 30. Looks like it's still true. So I know how to get rid of division by 3. I'm going to multiply everything by 3. Oh, kit and caboodle. Those 3 cancels. 3 times 8, 24. 3 times 4x, 12x. And 3 times minus 2, minus 6. I'll bring the 2x to that side, 14x. I'll bring the 6 to this side, 30. And 30 divided by 14 sure is darn close to 2. So the graph matches up with the algebra. I'm feeling good. No careless error. All right, so the roots of q of x. The q of x is 3x minus 1 squared minus 21, and roots are places where graphs cross the x-axis. So, sure looks like to me, I need 21 minus 21 equals 0. Sure looks like to me that I got to get 3 times 7 minus 21 equals 0. And that sure looks like to me that I need 3 times the square root of 7 plus minus squared minus 21 equals 0. You might want to replay that. Pretty important, actually. So what do we have? We got a cup shape up. We got 3. And we got, 1. Lost my train of thought. 1, negative 21. And we got to get up here to 0. Well, does it make sense that we have to move from the number 1 to the right and to the left? But we got to go up 21. So does it make sense that we start there? And if I got to triple something, then maybe I only want 1/3 of it to come out. But then I'm going to triple it. Do. That's going to get me the root on the right. And the negative one's going to get me the root on the left. So it looks like I got 7 units that have to get tripled. Yeah. And then if we're squaring, right? If we're squaring, that looks like we got a plus minus the square root of that distance. And then it looks like we're moving from the number 1. Now, I think I had the A theorem of 3, and I kind of can see all of the answers. I can kind of see all the answers over there. I can kind of see 7 is, it's what yeah. Let's see if we can do this. Multiplication by 3. Not sure I'm saying this the way I want to, but let's just let the numbers speak for themselves. Let's say we have a 5, 7. Better make it negative 11. 5 minus 11, okay, and an a term of 2, and we want the roots, which are up here. Well, it turns out 5 plus minus, you could use that immediately. You got to go up 11 units. Then we're dividing by 2. I tend to use that a lot more than the quadratic formula. I think it's quicker and easier. But just showing it, not saying much about it at this stage, but planting a seed. All right, let's see now. So we've got 2x squared minus 12x minus 5. What did I ask you to do with it? Sketch it maybe? So 2x squared, what's that tell me immediately? Cup shape up. Plus 20x. I know what that tells me. My y-intercept is on this side, but you don't know y yet. Minus 7, but I also know that that's that. Looks like the only thing I'm missing is the vertex. How do we get that? You're pausing the video and thinking. Minus b over 2a. Minus 20 over 4. Negative 5. Okay. How do I get the y value? Plug it in. There's minus 100, cut in half, minus 57. You can take more time than that. Right? You can take more time than that. You can plug negative 5 in, do it in all 3 places. I'm saving some time. How do you get from minus 57 to 7? I think you got to go up 50 units. What's the squared change from negative 5 to 0? Well, it's 25 units. Sure looks like. That's right. All righty. Let's see. We got ourselves 4a b to the minus 3, 5a minus 2 b to the 9. And I think I'm going to do this in the standard way. Each and every time, I'm going to simplify the parentheses first. We still got 4 over 5, nothing changing there. Looks like I got a to the 3. And it looks like I've got, I think I copied it right, b to the 12 to the negative 3. I'm going to flip it. So I got 5 b to the 12 over 4a to the 3. And now I'm going to cube it. And so my final answer, 125 b to the 36 over 64 a to the 9. All right, let's graph the exponential function. The key to graphing exponential functions quickly is making sure you know what b to the 0 and b to the 1 is, or are. B to the 0 is 1, b to the 1 is b. That unlocks the ability to graph 10, 2, x minus 3 plus 7. Okay, hopefully you're hearing this enough that is asymptotic behavior. It's really on the left side that our numbers tend to be close to 7. Y on the negative side of things, 2 to the minus 100 is 1 over 2 to the 100, for instance. That's so small, it's close to 0. 0 times anything, you're just left with the constant 7 over there. All right, so where was I? I want to jump a 10, and then I want to jump a 20. When do I get a jump of 10 to get to 17? When I make b to the 0 happen. So 3 makes it 2 to the 0. Anything to the 0 is 1. 1 jump of 10 on top of 7. And then the next number is 4. That's easier to see. 2 times 10, 27. Graph exponential functions pretty quickly once you understand what you're looking at. And I give you 4 days. I don't know how many days it's been since we've done that, 2 or 3. Hopefully that's starting to make a little more sense. So name it. I don't know what I'm naming. The inverse? Maybe I want the inverse. I don't know what I asked you. Anyway, we'll end with the perpendicular. 2x minus 7y equals 28. I'll just show you over 2 up 1. That's a 1-to-2 ratio. This is the y, right? Change in y, the change in x. 1-to-2. I'll draw a perpendicular. I don't know. I hope that's close. I'm good. I should go over 1 and down 2. Okay, that's a -2-to-1 perpendicular. So what's the major change you have to remember? If one's increasing, the other's decreasing, vice versa. And then just reciprocate. All right, so I can see that my slope is going to be -7/2. You can see it just by looking at it. But I like to bring the y's to the other side so they're not negative. Constants, not affecting the interplay between x and y. So 2 to 7 is our slope in this problem, right? Change in y, change in x. Because I'm getting y alone over here, right? Maybe I should, you're young at this. So let's see, 2 7's x equals y, right? There's your change in y over change in x, 2 over 7. So -7/2 is the perpendicular. I don't know what I put it through, this, that. X minus this gets you that. All right, and that should be getting easier too. Why? Because when I put this in there, I get 0, and 0 times anything gets rid of the product, and you got that. All right, so that's the end of that. I'm not sure how long these are taking, but you know, you can skim through them as you get confidence in certain areas, but it's good to see how each problem's done each day.